In this video, we're going to review the concept of atomic orbitals. First, let's take a look at the 1s orbital. You can see the nucleus in the center here, and the orbital itself is spherical in shape. The orbital refers to the area where the probability of finding the electron is high. Specifically, the electron has a 90% probability of being found inside the sphere. That means that there's a chance it could be outside the sphere, but that's fairly low. The area of the sphere also has a positive phase, and we'll explain what that means in the next slide. Since the shape of the orbital is spherical, that means that every point on the orbital is approximately the same distance from the nucleus. Now let's look at the 2p orbital. The 2p orbital, instead of being spherical in shape, has these two lobes. It also has a node in the middle. So in this case, the electron has a 90% probability of being in either of these lobes, and actually has a 0% probability of being anywhere in this node. Also, the 2p orbital has opposite phases. You'll notice that one of the lobes is darker and one of the lobes is lighter, and that's meant to represent the opposite phases. The 1s orbital was just one phase. Also, if we compare to the 1s orbital, the 1s orbital had an approximately equal probability of finding the electron at the same distance from that nucleus. Whereas with the 2p orbital, it's different. We have a good chance of finding the electron here, but not down here. Another thing to consider about the 2p orbital is there are actually three of them. There's one in the x-plane, one in the y-plane, and one in the z-plane. When you combine them together, they look like this. It looks kind of like an everlasting gobstopper to me. So this is why when we were doing electron configuration, we had those three lines. Each of those lines was for one of these orbitals, px, py, and pz. In the next video, we're going to look at how we take the s and p atomic orbitals and combine them to form molecular orbitals.